So in this next video, we'll be looking at problem solving with quadratics. So this is a really important topic and one that's used in a lot of professions, especially engineering and other mathematically based ones. And obviously we won't be jumping into that kind of depth in this lesson, but it's a bit of an introduction into how this is used. So we've got a method for solving these problems, and I'm just going to go through each step. There's 4 steps, and usually these problems are given to us in word form, and we've got to change it into mathematics. So the first one is the first step is we have to translate the words into algebra, and we generally use x as the variable. You can use any letter you want, I guess. However, because we've been using x, we're going to continue to do that. Now, a bit of a note here, it says remember to define your variable x, and we'll have a look at what that means in a moment. So step 2 is solve the equation using a suitable method. So we've been working on a few different methods, and we can use any of those, any suitable one of those, to solve our problem that we've transferred into algebra. Now, once we've done that, we'll get a solution, and sometimes these solutions are not acceptable. And what that means is we might be trying to find a length, like later in this video, we'll be trying to find a length, and if we get a negative number, that doesn't really make sense in terms of length. So we want to try and analyze our solution and see if what we got actually could happen. And the final step is a really important one, but often the one that gets forgotten the most is write your answer in a sentence. So you'll be given a word form question, you work out some solutions, and you should give that answer or the solution in worded form as well. So that's the final step, and let's have a look at an example now. So our example, a rectangle has a length 3 centimeters longer than its width, and its area is 42 centimeters squared. We've been asked to find the width of the rectangle. Okay, so the first thing we do, if we go back to our steps, the first step is to translate this into algebra and to define our variable x. So we'll do that now. So what I gather from this sentence is that if the width is x centimeters, so we don't know the width, so that's why we've given it the term x. The length is x plus 3 centimeters. Okay, now where I've got that from is the width. We don't know what that is, so I've given it this x because that could be anything. But we know the length is 3 centimeters longer, so x plus an extra 3 centimeters. Okay, so that's the first thing we have to do, just define our variable. All right, so we've defined our variable. That's the first part of our step 1. The next part is to put it into an equation from here. So we know that the width is x and the length is x plus 3, and we also know the area is 42 centimeters squared. So we know that the length times the width equals the area. All right, so I'm just going to put that in. So the length is, I'll put it right around the other way, it doesn't matter. So x times by x plus 3 equals 42. Okay, length times width is 42. That's our first step completed. So I'll just label that step number 1. All right, so let's go to step number 2 now. And step number 2 is for us to solve the equation using a suitable method. So what I want to do is expand these brackets. So I have x times x plus 3. So first I times the first part. X times x is x squared, plus x times 3 is 3x. Okay, and that equals 42. So I've just expanded that. Now what I want to do and what we've been practicing is getting all of these things on the same side and letting them equal 0. So to do that, I have to minus 42 off both sides. Minus 42 equals, and if I minus 42 off this side, I'm left with 0. All right, and now I've got a quadratic equal to 0 that I can solve. So I could put this into our quadratic formula and solve it algebraically. However, what I'm going to do is put it into the graphics calculator and use the solver in there to get our solution. So you can see I've put in our value for A is 1, for B is 3, and our C is -42. And if I press enter there, I'm given the value 5.15 and -8.15. So what that means is our x equals 5.15 or x equals -8.15. Okay, and that's the end of step 2. Now, step 3 is examine the solutions to see if they are acceptable. So let's have a look at these now. I might do this part in red. So step 3. So we've been given 2 answers for the length. The length could either be 5.15 or -8.15. Now, I mentioned earlier in this video that you can't really have a negative length. It doesn't make sense. Something can't be negative length at all. So this one does not exist. So you would write something like, as we cannot have a negative length, x must equal 5.15. Okay, and that's step 3. Now our final step is to rewrite this in a worded form. So step 4, in worded form, I'm going to write that the width is approximately, because it's not exactly, 5.15 centimeters, and the length is, remember it's 3 more, so 8.15 centimeters. Okay, so if you follow the steps, it's not too difficult to process, but just have to use what we've learned in our previous lessons, combined with a couple of new steps to get the solution. Okay, thank you.